Hello, my name is Vladimir Korikov, and this is the Domain-Driven Design in Practice course. In this module, we will discuss DDD concepts that we didn't cover in our sample project, and some further possible ways in which our application can evolve in the future. We will also look at some common N-type patterns programmers employ when they start applying DDD principles in practice. One of debatable topics in DDD is whether to always keep entities and value objects in a valid state or allow them to reside in an invalid state and check that state later on, for example before saving them to the database. This topic is best expressed with an example. Let's say we have a domain entity cargo with a max weight property. Let's also say it contains several items, each of which has its own weight, and there is an invariant saying that a cargo cannot contain a number of items the total weight of which exceeds the maximum weight the cargo can handle. This is how we could express the domain adhering to the always valid approach. You can see we first create a cargo with some max weight value, and then check that this maximum weight would not be exceeded in the addItem method call. If it is, we throw an exception signalizing that the invariant of the entity is violated. That way, we don't allow the class to enter an invalid state. This is, on the other hand, how we could solve the problem adhering to the not always valid approach. You can see we allow any number of products to be added to the cargo. To validate whether or not the invariants are broken, we introduce a separate isValid method. Both techniques has their own pros and cons. The main benefit of the always valid approach is that we as programmers can be sure the objects we are working with always reside in a valid state whenever we accept them as input parameters or get them as a result of some operation. On the other hand, the not always valid approach allows us to gather most of the validations for an entity in a single place and thus simplify the validation logic. So what approach to choose and why? Despite the benefits that the not always valid approach provides, I strongly recommend you adhere to the always valid approach. There are two reasons for that. First of all, it removes temporal coupling. With the opposite technique, you must always remember to call the isValid method before persisting an entity to the database or before executing some business-critical operation. This often ends up to be an error-prone way to build a domain model. Secondly, the always valid approach helps with the don't repeat yourself principle. In other words, it helps eliminate duplications which inevitably take place with the not always valid approach because of the necessity to validate domain entities multiple times during a single business operation. Overall, it is better to adhere to the guideline stating that all domain entities and value objects should always reside in a valid state and maintain their invariants during the full length of their lifetime. A violation of any invariant in the domain model should signalize a bug and lead to a failure in order to protect the persistent state. This principle is often referred to as fail fast and is one of the most important principles of software development. You can read more about it here. So, if all domain classes reside in a valid state, where exactly should one perform validations? In the example above, where should we check that an item can be added to a cargo? The best place to perform such validations is the boundary of the domain layer in the application services. You saw this technique in our project. Whenever we needed to validate whether a snack could be bought from a snack machine or a sum of money could be taken from an ATM, we performed validations in the viewModels first, and only after that performed the corresponding operation upon the domain entities. This way, we ensured all classes in our domain model always reside in a valid state. Otherwise, our domain classes throw exceptions which lead to application crash. One of the DDD concepts we didn't use in our sample application is factory. Factory is not a DDD notion per se, it was first described by the Gang of Four in their Design Patterns book, but it's still worth discussing. A factory is a class which is responsible for creation of domain entities. Sometimes creating an entity requires a lot of work in a sense that you need to retrieve some information from different places and combine different pieces of it together in a certain way. In this case, it would be unwise to commission this responsibility to the entity itself, because construction of an entity has nothing to do with exploiting it after that. Think about it this way. A car engine is a complex device, but it's not responsible for self-construction. That is what engine factories are for. Designing an engine which can build itself is in theory a feasible task, but such device would most likely be too expensive and unstable compared to a classic car engine. The same reasoning is applicable to domain entities. If the logic for creating them is complex, it is better to extract this responsibility to a separate factory class. That would help keep the entity simple and thus more maintainable. Just as repositories, factories create whole aggregates, not just separate entities in it. At the same time, don't add a separate factory in case the initialization logic is simple enough. Class constructors would be a better option in such situation. You saw that in our domain model we didn't introduce any factories. That's because there wasn't any complex business logic associated to the creation of our entities. Another important DDD concept we didn't discuss yet is domain services. A domain service is a class which doesn't have any state associated with it and which contains some domain logic. The best way to think about domain services is to view them as containers for the knowledge which doesn't belong to any entity or value object but is still essential for your domain. It might happen that an operation is related to some entity, but representing it as a method in that entity wouldn't make much sense. In this case, it is probably a good idea to delegate this operation to a domain service. An example here would be a car service. We don't entrust a responsibility to maintain a vehicle to the vehicle itself. It's just not the way it works in the real world. A better decision would be to introduce a separate domain service responsible for that operation. A question which often arises when people start thinking of domain services is how they differ from application services. The difference here is that an application service resides outside of the domain layer, whereas a domain service is inside of it. It means that application services are in charge of communicating with the outside world and shouldn't contain any domain logic. What they should do instead is delegate the execution to the domain classes, such as entities, repositories, and domain services. Domain services, on the other hand, do contain domain knowledge and shouldn't communicate with the classes outside of the domain layer, the two innermost layers in the onion architecture. We didn't have any domain services in our project, but at some point we could. For example, if we had a requirement to distribute a given amount of products evenly among several snack machines, that would be a task for a domain service, because it is a domain-related operation and it doesn't fit the responsibilities of any existing entity in our domain. There are several pitfalls programmers starting with DDD may run into, and it's important to know about them. One of such pitfalls is anemic domain model. If you try to follow DDD principles, then you are probably not subjected to this anti-pattern, but it's still worthwhile to know about it. Anemic domain model stands for separating data and methods working on that data to separate classes. It usually means that entities in such model contain only data and all domain logic is extracted to domain services. In our application, for example, anemic domain model would look like this. You can see the snack machine entity contains only data, money inside, money in transaction, and the collection of slots. All operations upon the snack machine are delegated to the snack machine domain service. In object-oriented programming languages, introducing an anemic domain model is generally a bad idea because it hinders application of many OOP design patterns and best practices. The most important drawback here is that it often leads to poor encapsulation. Note that the properties in the snack machine entities are all public. That's no coincidence. The only way to enable separation of data and logic into different classes is to expose the internal structure of domain entities and thus break their encapsulation. Such code is much harder to maintain because its invariance can be easily broken. You can read more about anemic domain model in this article written by Martin Fowler. Another anti-pattern I'd like to mention is fat entities. This anti-pattern resides on the other part of the spectrum of bad design decisions comparing to anemic domain model and basically stands for putting too much logic to entities. There is a fine balance between anemic domain model and fat entities, and it's sometimes hard to find it. So how do you know that you put too much logic to your entities? One of the clues is that your entities start having responsibilities that seem unnatural to them. For example, in our sample application, we could commission the duty to update the balance of the head office to the ATM entity. Such responsibility doesn't make a lot of sense in our domain because ATMs don't actually update the balance of our office. Nevertheless, we could do that, and that would be a sign of the ATM entity getting too fat. Another symptom of this anti-pattern is when domain entities start looking up data in the database or communicating with outer layers of the onion architecture. In other words, when we break isolation and allow the innermost layer depend on the classes from outer layers. To avoid falling into the trap of fat entities, you need to make sure your domain model is properly isolated, and all entities' responsibilities make sense from the domain point of view.